Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start 12th portion, part 1. Last class I finished 11th completely or 14th unit. Now I am going to start 12th standard, part 1, the solid state chemistry that I am going to start. We are mostly surrounded by the solid and we use them more often than liquids and gases. For different applications, we need solids with widely different properties. These properties depend upon the nature of constituent particles and the binding forces operating between them. Therefore, a study of the structure of solids is important. The correlation between structure and properties helps in discovering new solid materials with desired properties like high temperature superconductors, magnetic materials, biodegradable polymers for packaging, biocompliant solids for surgical implants, etc. From our earlier studies, we know that liquid and gases are called fluids, F-L-U-I-D-S, fluids, because of their ability to flow. The fluidity in both of these states is due to the fact that the molecules are free to move about. On the contrary, the constituent particles in solid have fixed position and can only oscillate about their mean position. This explains the rigidity in solids. In crystalline solids, the constituent particles are arranged in regular patterns. This is an important point. Regular patterns. Constituent particles are arranged in regular patterns in crystalline solid. Here in this chapter, we will discuss different possible arrangement of particles resulting in several types of structure. The correlation between the nature of interaction within the constituent particles and several properties of solids. How these properties get modified due to the structural imperfection or by the presence of impurities in minute amounts would also be discussed. Solid structure is very, very important, solid state. If you will see from the microscope or electron microscope, then you will find every structure, every solid or liquid or gases, they have fixed structure. Their arrangement, ions or atoms are arranged in a different way. That's why their properties will differ. Then here in solid state chemistry, we will study about the structure of solid and their structure is related to their properties. Under a given set of conditions of temperature and pressure, which of these would be the most stable state of a given substance. Under a given set of condition of temperature and pressure, which of these would be the most stable state out of a given substance? These structures depends upon the net effect of two opposing factors. In intermolecular forces, these two opposing factors that will tell about the structure. Actually, temperature and pressure decides many properties of the structure, and these you can say affect opposing factors. These two opposing factors, intermolecular forces, tend to keep the molecules or atoms or ions. Molecules may be of atoms or may be of ions. Then these intermolecular forces tend to keep the molecules closer, whereas thermal energy tend to keep them apart by making them move faster. These intermolecular forces want to bring the molecules closer, and thermal energy tend to keep them apart by making them move faster. At sufficiently low temperature, the thermal energy is low, and intermolecular forces bring them so closer that they cling to one another and occur fixed positions. At low temperature, thermal energy is low at low temperature, and intermolecular forces bring them so close that they cling to one another and occupy fixed position. These can still oscillating, even they are very close, these can still oscillating about their mean positions, and the substances exist in solid state. Some characteristic properties of the solid state I am telling now. First characteristic properties, that is they have definite mass, volume and shape. This is the first characteristic properties of a solid. They have definite mass, volume and shape. Second, intermolecular distances are short. The distance between the molecules or atoms or ions are short. Third, intermolecular forces are strong. Fourth, their constituent particles like atoms, molecules or ions have fixed position and can only oscillate about their mean positions. Fourth characteristics I am telling you, their constituent particles maybe atoms, maybe molecules or ions, have fixed position and can only oscillate about their mean positions. Fifth characteristics properties, they are incompressible and rigid, means they are hard. Solids are hard. They are incompressible and rigid. Now I am going to tell about the amorphous and crystalline solid. Solid is divided into two parts, two types you can tell, basically divided into two. First is amorphous solid and second is crystalline solids. Solids can be classified as crystalline or amorphous on the basis of the nature of order present in the arrangement of their constituent particles. That according to the arrangement, order means here like that, just like in the class you people are sitting, 5 students are sitting in one bench, in second bench again 5, third bench again 5, fourth again 5, fifth bench again 5, in the middle row also 5 students are sitting, and third row also 5 students are sitting in all benches. Then all of you are sitting in a order, all of you are sitting in a fixed fashion, in a order, that is called order, a special arrangement. Then in solid also, atom, molecules and ions may be arranged, may or may not be arranged in order. Sometimes they can arrange in an order. Sometimes their arrangement may be for short, and after that again it will be not arranged properly. Then here order means arrangement. Okay, arrangement of atoms, ions or molecules. Then here these solids are classified as crystalline or amorphous on the basis of the nature of order present in the arrangement of their constituent particles. A crystalline solid usually consists of a large number of small crystals. A crystalline solid usually consists of a large number of small crystals, each of them having a definite characteristic geometrical shape. Each crystal have a fixed or characteristic geometrical shape. In a crystal, the arrangement of constituent particles may be atoms, molecules or ions. Then arrangement of constituent particles is ordered. They are arranged in an ordered way, in a particular way. It has long range order. Crystalline solid in atoms and molecules, they are arranged in a long range order, which means that there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. Sodium chloride and quartz are typical example of crystalline solid. Sodium chloride NaCl and quartz is SiO2, silicon oxide. Then these are the example of crystalline solid. Now this come to the amorphous. An amorphous solid, amorphous means, this is the Greek word, amorphous means no form, no fixed form. An amorphous solid consists of particles of irregular shape, no regular shape, irregular. The arrangement of constituent particles like atoms, molecules, or ions. In such a solid has only short range order. In crystalline it was having long range order, but here only short range order. In such a arrangement, a regular and periodically repeating pattern is observed over short distance only. Only for a short distance their regularity or repetition is observed, only for short distance only. Such portions are scattered. Such portions are scattered and in between the arrangement. Means only in the beginning maybe arranged in a proper way, after that no fixed arrangement, scattered. And that is in between the scattered in between the arrangement is distorted. After that distortion will be there. Such portions are scattered and in between the arrangement is disordered. The structure of quartz crystalline and quartz glass. Actually here two example of quartz only. The structure of quartz. Quartz may be crystalline also and amorphous also. Okay. The quartz, the structure of quartz, that is the crystalline and quartz glass. One is quartz, other is quartz glass. Quartz glass, that is amorphous. Okay, I will try to send these two picture. Okay, that in first quartz you will see that all are arranged in a proper way. It is just like benzene structures are arranged. Many benzene structures are there, like that way it is arranged in quartz, proper arrangement. But in quartz glass same structure is there, but not like that in a proper way. It is not arranged in a proper way in quartz glass. That is, quartz glass is the amorphous and only quartz, that is the crystalline structure. Then in quartz it is arranged in a proper way, but in quartz glass arrangement is not in a proper way. While the two structures are almost identical, okay, but some yet you can say, while the two structures are amorphous, while two structures are almost identical, yet in the case of amorphous quartz glass there is no long range order. The structure of amorphous solid is similar to the liquid. You can tell the structure of amorphous solid is similar to the liquids, similar to that of liquids. Example I am telling you, glass, rubber and plastic are typical examples of amphoteric solids. Question is asked. Then glass, rubber and plastics are typical examples of amorphous solids. Due to the difference in the arrangement of the constituent particles, the two types of solid differ in their properties. Okay, these two, both crystalline and amorphous, they differ in their properties. Okay. Now more I am telling about this. Crystalline solids have a sharp melting point. Crystalline solids have a sharp melting point. On the other hand, amorphous solid softens over it will be soften over a range of temperature and can be molded and blown into various shapes. Amorphous solids soften over a range of temperature up to large temperature, that will be softened. It vary in many temperature, at many temperature it will be soft and can be molded and blown into various shapes. On heating, they become crystalline. This amorphous, on heating, it becomes crystalline at some temperature, not always. At some temperature, it will be crystalline. Some glass objects from ancient civilization are found to become milky in appearance because of some crystallization. Some old, I am talking about, some glass objects from ancient civilizations are found to become milky in appearance because of some crystallization. Like liquids, amorphous solids have a tendency to flow. This is a very, very important point. Okay, like liquids, amorphous solids have a tendency to flow, though very slowly, but it has tendency to flow. Therefore, sometimes these are called pseudo solids. Pseudo, P-S-E-U-D-O, pseudo, P-S-E-U-D-O, pseudo solids or super cooled liquids. Amorphous are called super cooled, particularly glass. Glass is called super cooled liquids or pseudo solids. Okay, glass panes fixed to window or doors of old buildings are invariably found to be slightly thicker at the bottom than at the top. This is because the glass flows down very slowly and makes the bottom portion slightly thicker. Again, I am telling little more. Crystalline solids are isotropic. There are, according to the arrangement, it is given two terms, isotropic and anisotropic. Then these crystalline solids are anisotropic in nature, that is, some of their physical properties like electrical resistance or refractive index show different values when measured along different direction in the same crystal, because that they have different arrangement. In crystalline solids, they in different direction, different arrangement will be there. In one direction, suppose A, B are arranged. In a molecules, in a crystalline, suppose like NaCl, sodium chloride. Just in a general way, AB you can tell. Then it may be arranged like A, AB like that they can arrange, or A, B like that way it will be arranged. Then if you will see a structure, then you will find all A are arranged, and between the A, B are there. Then again you will see, then every between the two A, one B is there. With every 2A down, B will be there. Then again all B will be in a B will be in the one row. A will be the one row. Like that way, all A, B will be arranged. Horizontally you will see, horizontally it is arranged in one way. But if vertically you will see from up to down, then you will find that their arrangement is becoming different. Then it is a directional. Then in every direction their properties will be different. That is called anisotropic. Anisotropic. If you draw a line horizontally between the, you can say, same molecules, then you will find one line, all are coming in one line. And vertically, if you will draw, then you will find again AA are coming in one line, BB is also coming in a proper way arrangement. But in horizontally arrangement is different and vertically arrangement is different. Okay. Then like that way, they actually overall crystals are in a fixed position. They are arranged in a proper way, but in a X direction or Y direction, their arrangement will feel different. Like that way, diagonally you will see, then also you will find they are differing. Means between the 2A, B is coming. Every between the 2A, B will come. Diagonally also, horizontally also, vertically also. Their arrangement will be little different. That's why it is called anisotropic. Crystalline solids are anisotropic in nature. That is, some of their physical properties like electrical resistance or refractive index show different values when measured along different direction in the same crystal. This arises from different arrangement of particles in different direction. Okay, I will try to send some one diagram related to this. Okay, since the arrangement of particles is different along different direction, the value of same physical properties is found to be different along each direction. Now come to the amorphous. Amorphous solids on the other hand are isotropic in nature. Isotropic, that was anisotropic, but amorphous are iso means same. Isotropic in nature. It is because there is no long range order in them and arrangement is irregular along all the direction. Irregular. They are not arranged in these things proper long. They lack, or you can tell there is no long range order. They are not. They don't have no you can say long range order. They are arranged irregular way. Arrangement is irregular along all the direction. Therefore, value of any physical properties would be same along any direction. Okay. Now I will summarize. I will summarize this properties. Then here question is asked. That's why I am summarizing distinction between crystalline and amorphous solid. Question is asked. Distinction, differences between crystalline and amorphous. Then if you talk about the shape, already I told you, only I am briefing you. Shape, then crystalline solid, definite characteristics geometrical shape, and amorphous irregular shape. Melting point, then crystalline melt at a fixed and characteristic temperature. At a fixed temperature only crystalline substance will melt, but amorphous gradually soften over a range of temperature. It is soft over a range of temperature. Now cleavage properties. Cleavage properties means breaking. When cut with a sharp edged tool, I am talking about the crystalline, when crystalline substance is cut with a sharp edge tool, they split into two pieces and the newly generated surfaces are plain and smooth. Means if you will see after the cutting surface, you will see the surfaces, then you will find surfaces are plain and smooth. But here amorphous, when cut with a sharp edged tool, they cut into two pieces with irregular surfaces. Now their surfaces will be irregular. Heat of fusion. In crystalline substance, I am telling you, they have a definite and characteristics heat of fusion. Okay, and here amorphous, they don't have definite heat of fusion. Now come to the anisotropy. Anisotropy, then you know in crystalline, anisotropic in nature, crystalline substance are anisotropic in nature, but amorphous is isotropic in nature. And this, what type of nature they have? This crystalline, the crystalline is a true solid. Crystalline substance is a true solid, and this amorphous, this is the pseudo solid, pseudo, pseudo solids or supercooled liquid. Question is asked, this particular question is asked about the amorphous. Then example is the glass is a supercooled liquid. And this order in arrangement of constituent particles, how they are arranged, then you know that in crystalline solids they have long range order, they are arranged in a long range order, and here amorphous only short range order. Then this I have given, you can say distinction means differences between crystalline and amorphous. Amorphous solids are useful materials. Glass, rubber and plastics find many applications in our daily lives. Amorphous silicons is, amorphous silicon I am talking, as the question is asked, that's why listen carefully. Amorphous silicons is one of the best photovoltaic material available for conversion of sunlight into electricity. There you will use a photovoltaic material as a photovoltaic material. Amorphous silicon is used, and that is converted into sunlight. It converts sunlight into current, electricity. This is the, I told you how it is useful, very useful. Then here actually this particular question is asked. Okay, then amorphous silicon, sometimes only silicon, it is called only silicon. Now I am going to discuss these things. Classification of crystalline solid. Classification of crystalline solid. Here all things we have discussed in the, you can say, previous classes. Many things already I have discussed about the, you can say, molecules, but here is the right place to tell. Most of solid substances are crystalline in nature. Here I am discussing classification of crystalline solids. Okay, most of solid substances are crystalline in nature. For example, all the metallic elements like iron, copper and silver, all are crystalline. Non-metallic elements like sulfur, phosphorus and iodine are also crystalline, and compounds like sodium chloride, zinc sulfite and naphthalene form crystalline solids. All are crystalline solids. Crystalline solids can be classified on the basis of nature of intermolecular forces. Intermolecular forces is the main things. Then on the basis of intermolecular forces, crystalline solids are classified. Okay. Then it is classified into four categories. As for example, what are the four categories? Then first you can tell molecular, second ionic, third metallic, and fourth covalent solids. Four are the crystalline solid: molecular solid, ionic solid, metallic solid and covalent solid. Okay. Now one by one I will tell little more about these four. Molecules are the constituent particles of molecular solids. How molecular solid is formed? Then it is formed by, you can say, molecules. Molecules are the constituent particles of molecular solid. Molecular solid is made from molecules. Okay. Then these are, there are, you can say, further, these molecules are solid. I am talking about molecular solids are further subdivided into, you can say, four. That is the non-polar molecules. Okay. Polar molecules, hydrogen bonded molecules. Okay. Molecular solids also you can tell. These molecules are further divided into these three. First, non-polar molecules, second, polar molecules, and third, hydrogen bonded molecular solids. Then non-polar molecule solids, non-polar molecular solid. Then here again you can understand that non-polar molecular solids, they are comprised of either atoms, they may be made from, you know that from the atom molecules are formed, same things are there. They are comprised of either atoms, for example argon and helium. On the you can say argon, I told you, or helium, they are you can say monoatomic gases. Argon and helium are monoatomic gases only. They are made from the atoms, single atoms. Okay. Here again I want to tell you that you already, I have discussed many times that any substance, molecules can be converted, if molecules are there, that they can exist in three forms: solid form, liquid form, gaseous form. You know, solid, liquid, gas. If pressure is high and temperature is low, then substance can be converted into, gas can be converted into the liquid. Liquid further can be converted into solid. Correct? If temperature is very high, pressure is less, then gas. Correct? You know that these are the main instrument to control the substances: temperature and pressure. If temperature is less, then molecules will be, temperature is less, then their molecules will come closer, because temperature is less, kinetic energy will be less, correct, and pressure is high. Then due to these two things, low temperature and high pressure, molecules will come closer to each other. They will become, you can say, if they are in gas, then they will convert into the liquid. And again further, temperature is less and pressure is high, then that can convert into the solid also. When you are heating, then what is happening? If you are, it is solid there, if you will heat high temperature, then atoms will be, molecules will be separate out, correct, and pressure should be less. Then now you can see solid will convert to the liquid, and again further high temperature, liquid will convert to the gas, correct, further pressure should be less. Then all are convertible. This you keep in mind. Then here I am talking about non-polar molecular solids. They comprise of either atoms, for example argon or helium, or they can comprise of molecules formed by non-polar covalent bonds. Non-polar, no charge, non-polar covalent bonds. For example, H2, Cl2 and I2. Okay. In these solids, the atoms or molecules are held by a big force, big dispersion force or London force. Okay, already we have discussed. These solids are soft and non-conductor of electricity, because charge is not there. Hence, it is non-conductor of electricity. They have low melting point and usually in a liquid or gaseous state at room temperature and pressure. Only at room temperature and pressure they are in gaseous state. Otherwise, it may convert to solid. Second, polar molecular solids. Polar molecular solids. The molecules of substances like HCl, hydrogen chloride, HCl, SO2, etc. are formed by polar covalent bonds. Means charge is there. Polar means charge. The molecules of such solids are held together by relatively stronger dipole-dipole interaction. Now these molecules are just you can say held together by relatively stronger dipole-dipole interaction. These solids are soft and non-conductor of electricity. These are also non-conductor. Why? They are held together, they are not separate. To conduct, even it is a polar, means charge is there, but they are not conducting. They are non-conductor because they are not separating. If they will separate only, then they can conduct, but they are not separating. Then these solids are soft and non-conductor of electricity. Their melting points are higher than those of polar molecules and non-polar molecules. Their melting points are higher than those of non-polar molecular solids. Yet most of these are gases or liquids under room temperature and pressure. They are gases or liquids. Solid SO2 and solid NH3 are you can say some example of this type of solid. Polar molecular solid example is solid SO2 or solid ammonia. Ammonia is a gas. You know, ammonia exists in the solid form also, liquid form also, gaseous form also. Solid ammonia, liquid ammonia, gaseous ammonia, just like a water. Water also exists in three forms: ice, liquid water, and water vapor. Okay, hence you should not think that it exists, ammonia only exists in the gaseous form. It can exist in all three forms. Nitrogen also, you know, liquid nitrogen is also there. Nitrogen is gas. Hydrogen is also gas. But all exist in the, it can exist in all three forms. Now I am telling about hydrogen bonded molecular solids. Okay, hydrogen bonded molecular solids. Then here the molecules of such solid, the molecules of such solids contain polar covalent bond. This is also polar covalent bonds between. H is common always because it is hydrogen bonded molecular solid, hence hydrogen is must. Hydrogen will be there. Then here in such solids, such solid contains polar covalent bonds between H and other maybe F, O or N atoms, means electronegative atom. Fluorine is most electronegative, you know. Oxygen is electronegative, nitrogen is electronegative. Then there will be, these are the, you can say, polar covalent bonds. They will have polar covalent bonds between H and any electronegative atoms. Example, F, O or N atoms. They have a strong hydrogen bonding. And a strong hydrogen bonding binds molecules of such solids like H2O, ice, as for example, a solid. They are non-conductor of electricity. These compounds are non-conductor of electricity. All three, I told you, are non-conductor. Okay. And generally, they are volatile liquids or soft solids under room temperature and pressure. Okay. So about the water, you should understand it is a non-conductor, that is in the form of solid, ice. But if it is in liquid form, liquid water, then I can say it is a bad conductor of electricity, means current will flow. Current will flow through the water because in liquid water, in liquid state I am talking about, H and O, H plus OH ion will be there. H plus and OH ion will be there. It is feebly ionized, not too much ionized, very less. That's why it will also, current will flow through water, but it is very, very less. Badly, you can say conductor. It is badly conductor. Current passes. That's why when you are wet, you should not touch the, I can say, loosely electric wire, because current may pass through your body. Because if it is wet, it is a body contains water. In our body, you know that 70%, around 70% water is there, and outside also water is there. If you are coming from the bathroom after taking bath, then current can pass through your body. That's why one should make a distance. It is a badly conductor, not good conductor. Okay. Then this I have told you about this crystalline solid. Then first I have told you about the molecular solid. In molecular solid also 3 categories I have told you. Now next categories I am telling you ionic solid. Ionic solid. Okay. Ions are the constituent particles of a ionic solid. Such solids are formed by the three-dimensional arrangement of cation and anions bound by a strong Coulombic forces, also called electrostatic forces. These solids are hard and brittle in nature. These solids are hard and brittle in nature. They have high melting and boiling points. Since the ions are not free to move about because they are solid. Here you are studying solid. Okay. Since the ions are not free to move about, they are electrically insulator, means current can't pass. They are electrical insulators in the solid state. However, in the molten state or when dissolved in water, the ions become free to move about and they conduct electricity. Even I told you polar charge is there, but they are close packed. They can't move. Then it will be non-conductor, or you can tell behave as an insulator. But if they are in a molten state or liquid state, then they are free to move. That time they will conduct electricity. Then I told about the ionic solids. In solid state they are non-conductor or insulator, but in melting condition or in solution form they can conduct electricity. Now next is metallic solids. Metals are orderly collection of positive ions. Metallic bond also you should know what is metallic bond. Here you can understand very easily. Metallic solid, all metals are solid, you know. Then metals are orderly collection of positive ions. Positive ion, I am like iron, copper, silver. Then positive collection of positive ions surrounded by and held together by a sea of free electrons. Large number of electrons will be there. Then now we will ask from where these electrons came. Then these electrons came only from that atoms. Cations, they are ions, positive ions, then they will lose the electron. Obviously they became positive by losing the electron. That electrons are there. Because many atoms cation will be there. Hence obviously large number of electrons will be there. And electrons are negatively charged. And these are positively charged. Cation like copper ion, ferrous ion, silver ion, all are positive ion. Then these two different type of charges are there, then they will held to each other. Okay. Then metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. These electrons are mobile and are evenly spread out throughout the crystal. Each metal atom contributes one or more electrons towards the sea of mobile electrons. These free and mobile electrons are responsible for high electrical and thermal conductivity of metals. Metals will be, you can say, conductor. It will behave like a conductor, and it is also thermal conductivity. It will show thermal conductivity due to the mobile electrons. Electrons can move. When an electric field is applied, these electrons flow through the network of positive ions. Similarly, when heat is supplied to one portion of a metal, the thermal energy is uniformly spread throughout by free electrons. Another important characteristic of metal is their luster and color. A special shining will be there, luster. Metals is there luster and color in certain cases. This is also due to the presence of free electrons in them. Metals are highly malleable and ductile. Okay, means you can make wire also, and long wire you can make, and you can just because the ductiles are also there, malleable and ductiles, then you can also make it is a thin, very thin, and long also you can make. Okay, then this out of this crystalline solid that I discussed now, molecular solid I discussed, ionic solid I discussed, and also I discussed metallic solid. One more is a covalent solids that I will discuss in the next class. Okay, thank you.